Buzz Lightyear to Star Command. Do you read me? No, I'm not going to be Buzz Lightyear today, but, you know, some say I could be Buzz Lightyear. To infinity and beyond. Yeah, I'll try it again later. Anyway, we're going to continue in lesson 21 talking about angle relationships. And last time we talked about the different types of angle relationships that are formed when you have a transversal that cuts through parallel lines. We're going to continue talking about that today. Well, this time we're going to actually find lots of missing angles, angle measures with given information. We're going to solve some different things for angle measures as well. So our goal is to find missing angle measures when parallel lines are cut by a transversal. And our success criteria is very similar to the last one, where, again, you got to know what parallel lines are and what a transversal is, because that's what's forming what we're doing. And then there's a bunch of angles that are formed. And we're going to talk about the relationships between corresponding angles again, alternate interior angles, alternate exterior angles, vertical angles, and same side interior angles, and whether like the angles would be congruent, supplementary. Those are the main ones for what we're working with. And we did talk about those last time. So just as a reminder, corresponding angles when you have parallel lines with the transversal are congruent. Same thing with the alternate interior, alternate exterior, vertical angles, and same side interior angles add up to equal 180 degrees. They are supplementary. So let's solve some problems with those. So on page, in your notes, on page 194, we're on page 194 in your notes book. We're going to take some notes here. We're going to figure out some different missing angle measures. Let's first look at number 2. So it says, let's recognize vertical angles to find each measure. So we're going to first two, we're going to look at vertical angles. We're trying to find the measure of angle A. So the measure of angle A is right here. And based on the information we're given, we can find the measure of angle A. Maybe you know, it's 55 degrees. Why is it 55 degrees? It's because this 55 degree angle and this angle A are vertical angles, and vertical angles are congruent. So vertical angles are congruent. Okay, so then let's find the measure of angle B. How can you find the measure of angle B? Well, that's 65 degrees, because it is across from the 65 degree angle here, and those are vertical angles which are congruent. So based off of that information now, we actually have the measure of angle A, which is 55, and the measure of angle B, which is 65 degrees. 55 degrees, 65 degrees. Probably would be nice if it wasn't so thick of numbers. All right, let's look at number 4. Use alternate interior angles to find each measure. Now we want to find the measure of angle C. So is there any angle that we can, there's nothing, no alternate, there's no vertical angles to C, but we're going to look for an alternate interior angle measure that goes with C. So I would say C, and parallel lines, we only have 2 of them right here. So transversal that goes through that, C, would actually be congruent to angle B, which we said is 65 degrees. So the measure of angle C then is 65 degrees. Okay? How about the measure of angle D? D, we don't know any of these other ones around them, but we know D is an alternate interior angle to this one, the 65 degree angle, because they're on the alternate sides of the transversal and they're on the interior of those parallel lines. So that one is 60 degrees. So we're locating alternate interior angles for those two. Okay, now let's locate a same side interior angle pair. We're trying to find, in number 6, the measure of angle E. I see the measure of angle E is right here. Okay, measure of angle E, if we're looking for same side interior, that means it's on the same side of the transversal, which looks like a transversal right here, and on the interior of the green parallel lines. Remember, same side interior angles, same side interior angles are supplementary. Supplementary. So that means that the measure of angle E and 60 has to add up to 180. So if I take E plus 60 has to equal 180, I subtract 60 on both sides. Some solving equations. The measure of angle E is 120 degrees. Those two should add up to be 180. Now, what is another way to find the measure of angle E? Well, we already found the measure of angle D, which was 60 as well. So if this one is 60, and maybe you recognize this right away, 60 and E also has to add up to 180 because it's a linear pair. So since those are a linear pair, they also add up to 180 degrees, and we know one of them was 60, so the other one has to be 120. Let's look at a corresponding angle example. Number 7. We're trying to find the measure of angle F. Now we have a bunch of stuff here, but is there a corresponding angle to F, meaning it's in the same spot, just at a different intersection, and looks to be the same degree measure? I see one. I believe that F would be the same in the same spot as this 60-degree angle. So that means F is also 60 degrees. But you might look at this and say, I know F is 60 degrees a different way. Well, what is that way? If you look right here, it's a vertical angle to D. F and D are vertical angles. So F and D are also the same, meaning it's also, so angle F and angle D are vertical angles. And they are congruent then. All right? All right, go to number 8. We got a whole different problem here. We've got two parallel lines, P and Q, and we've got a transversal that goes right through it. So the question says, lines P and Q are parallel. Give 3 ways to reason that angle 1 and angle 7 are congruent. So how can you determine that angle 1 and angle 7 are congruent? 3 different ways. Okay? Now, a couple of the ways are easier than, like, one way is way easier than the rest. For one, I would say, if you didn't catch this, they are alternate interior angles. And since they're alternate interior angles, they are congruent. There's my angles symbol. Now, can you come up with another way why they're congruent? Well, I would say angle 1, I'm going to move this out a little bit because it's covering up the 1. Angle 1 is congruent to angle 3 because they're vertical angles. And angle 3 is congruent to angle 7 because they're corresponding. They're in the same spot, just in a different intersection. And if 1 is congruent to 3 and 3 is congruent to 7, then angle 1 is congruent to angle 7. Okay, there's my second reason. Maybe you came up with a different second or third reason, but I don't know, similar to that, I could say angle 1 is congruent to angle 5 because they're corresponding. I'll put this in parentheses. And then angle 5 is congruent to angle 7. Why are they congruent? Because they're vertical angles. And then if 1 and 5 are congruent and 5 and 7 are congruent, that means that angle 1 has to be congruent to angle 7. So you see there's all these connections between different types of angle pairs, and you just got to know the relationships in order to find all these different connections. As you can see, there's multiple ways to get to the fact that angle 1 and 7 are congruent. Now, if you turn the page, we've got a couple of problems on this page. Number 9, if you look at that big diagram to the right, there's a whole bunch of stuff going on over there. It says in the diagram, ABCD is a parallelogram. List all angles that are congruent to angle 1 and all angles that are congruent to angle 8. For the angles listed below, tell how you know whether they're congruent to angle 1 or 8. So if I look at angle 1, like, this is a good time for you to pause it and try them. But angle 1, I would say it's congruent to angle 3 because they're vertical angles. I would say it's congruent to angle 5 because they're in the same spot. They're corresponding angles. I would say it's congruent to angle 7 because they're alternate exterior angles. I would say they're congruent to angle 13. Corresponding angles, just in a different spot here. I would say they're congruent to angle 15. Alternate interior or alternate exterior angles there. Now you could also then say angle 12, angle 11 as well through the grapevine, because if 1 is congruent to 15 and 15 and 11 are the same, so then 1 would be congruent to 11. I think that's all of them. If you got more, give those reasons. But so angle 15, we said 6, 15, and 14. 15 is congruent to 1. And that one we said they're alternate exterior angles. Let's see what's congruent to 8. So 8, same, angle 6 is definitely one of those because they're vertical angles. So I'm going to use a different color, angle 6. With 8, I would say 12 is a corresponding angle. It's in the same spot at a different intersection. And 4 is also a corresponding angle. 2 is an alternate interior angle. And also then on the other one, it would be 10 would be an alternate interior angle. And both of those are actually congruent to angle 14 and 16 for other reasons. Now, it's asking why is something congruent to angle 6 for letter C here. Vertical angles. So angle 8 is congruent to angle 6 because they're vertical angles. And last one is angle 14. I did say that it's congruent to angle 8. But the way we get there, let's just say angle 8 is congruent to angle 10. Because alternate interior angles. Is angle 10 congruent to angle 14? If I look at that, they're corresponding. They're in the same spot. And that means angle 8 would be congruent to angle 14 as well. All right. Last question that we're going to discuss is number 10. And then I'm going to have you try on your own. Well, let's do number 10 real quick. Reasoning about transversals and congruent angles can give you information about different polygons. In the parallelogram found by these lines, what do you notice about diagonally opposite angles? So basically 8 and 14. We said they're congruent. So let's just see, do we say 3 and 9 are congruent? Would that work as well? Let's say 3 would be congruent to 15, and 15 would be congruent to 9 because they're alternate interior. So those are congruent as well. So opposite angles in the parallelogram would be congruent. And that's true actually about all parallelograms. So I know we're running, this is going a little bit long here, so I want you to try numbers 11, 12, and 13 all on your own. And if you have questions, don't hesitate to ask. You can ask me that next time. But just to recap what we talked about today, we're working on finding actual angle measures when we have certain angle measures given, and just knowing that corresponding angles are congruent to each other. Alternate interior, alternate exterior, vertical angles, they all show congruence, and same side interior angles, if you find those, they're supplementary. And this is all dealing with parallel lines and a transversal. That's lesson 21.1. We'll see you next time. Sorry, I mean 21.2.